Ciao. Nice to see you all here. It's my first time actually in Venice. I really enjoyed that, and thanks for having me. So today's talk will be how to migrate and what steps we need to migrate to the Gradle version catalog and the convention plugins. Version catalog is popular and well known since January, but convention plugins were always kind of hard stuff. But I'm here to promise you and to show you that it's not that hard, and usual Gradle plugins are different real in a different realm, and the convention plugins are just to help us, and they help the whole team to share the build logic and actually accelerate the build times. So I'm Merabi Kutalia, Android GD. You can find me on Twitter, LinkedIn, ask me any question regarding the Android, Kotlin. So yeah, just get connected. Let's start with the standard Gradle stuff, which we have in every project. Every Android Studio project starts with the Gradle scripts, which are scripted in a Groovy language. And it is the easiest for everyone, for beginners, for the small projects, and to scale up from this initial stuff. The pros are very obvious. It's easy to set up, and there are tons of examples. But here's the drawback of these examples. It's not standardized. Everyone has its own version of the same script, the same representation. Some of them are written in the newer version of the Groovy. Some of them written in the, some of them have the defined type. Some of them are just kept as a script, and it's very hard to follow. And when you open a large project, you immediately see that different people wrote those scripts, because scripts are so different, but doing the almost same thing. That in other projects, you immediately see this different flavor, how they write the Groovy scripts. Plus, it's not type safe in regards to how we define the dependencies and how we define our functions in the Groovy. So we lack type system here to save us and actually save some time during the compilation. I mean, when you have the error in compile time, you know, and it's guaranteed that you are safe. Second is the manual version management, which is let's say very time consuming and plus nerve breaking, because Android Studio has its own dependency management tool, which is buried somewhere in the top menu, but it's there. So it lists all your dependencies and provides some suggestions that, oh, okay, this is a new Kotlin version. Oh, okay, there's a new version for this AndroidX library, and why don't you update it? But when you click the update, there's a new story appears, and it completely depends how you configure your Gradle script, because most of the times we use extension, these X blocks in our root Gradle script, which basically provides us different version numbers and so on. So we mostly extract those library versions in these X blocks. When we want to update those versions from the Android Studio, when we click it, sometimes it updates this X block variable, but most of the times it directly applies this new version number to the dependency. So now you have two different sides of the dependency, like dependency with the exact number and the library version without the dependency. So you end up having two different numbers in the project, and it's very hard, and nothing can fix it. and it this up lots of Stack Overflow answers, wrong answers, which are accepted, how to fix the Gradle script builds, and so on. This is typical extension block, how it looks like, nothing fancy. Most of us have done it. I'd say probably all of us at some point. There's no shame. It's okay to do this, and it depends really on the project. In a small project, it's really okay to do this. And if you are the only developer, why not? Plus, it's easy to maintain. But the next step, it's BuildSrc module, which introduced with Kotlin. Everything on the paper, everything looks good, and it was looking good back then. But then, some time after the people experienced this BuildSrc, there were different opinions about this. So let's get through it. The obvious advantage is the code completion, because now Android Studio can give you some tips, because it's Kotlin compiled, so Android Studio knows what to suggest. So that's cool. Also, you have ID support, which is navigation. I mean, command click or command B, whatever you prefer. You can navigate between libraries, library versions, and so on. So that's cool. And you get type safety because you write in Kotlin. So everything is good till now. Okay, what are the drawbacks of using this approach? So drawbacks are not very obvious if you are not experienced with different project setups, scaling. But here they are. So first one is obvious. Of course, it's not very trivial to set up, because it's a different module. Everyone on the internet has their own approach how to do this properly, as usual. Every GitHub project sets up in a different way, and if you want to actually accelerate your development pipeline, for example, have some kind of bot in a GitHub to update those dependencies instead of you, or to suggest what are the new versions for this, and then automatically merge that pull request. It's not very easy to do with BuildSrc either, because as I said, everyone has its own implementation. So at some point you need your own custom helper script or something for that bot to actually integrate into your project, and this is scan those dependencies and then replace the version in the code. Second one is that it's not very known issue, because most of the developers just disregard this. But every version update in the BuildSrc, we lose the build cache. So we lose the cache for the BuildSrc module, but we lose the cache for the project, because it's not the composite build, so build is not included in the project. So yeah, for a small project and the hardware we have now, it's most of the times it's negligible, and we are okay. Like how many times do we update the version? But imagine scaling. Always imagine scaling where you are working in an enterprise business or for a very large company. So you don't update versions like quarterly or something like that. So you update versions gradually, and your builds are on the CI server. Cache is everywhere on every developer's machine, sometimes on a remote machine. So the cache is really valuable thing, and we have to be more careful with it. The last part is Android Studio dependency update again. So Android Studio will try to update your library versions, but it will fail. So trust me, if you don't believe me, you can pull any codes from any project from the GitHub, open Android Studio, which uses BuildSrc, and try to update that one, and yeah, it will fail. And okay, what we can use to fix all these problems? The question stands like this. Before we move to the question, I forgot to show us, this is how BuildSrc looks like if some of you are not well into that BuildSrc stuff. So this is a typical module structure. You just have libraries, versions, and build KTS. So to save from this misery, we have version catalogs from Gradle. Just minor downside, this is available in Gradle 7.4, this stable version. So if you want to use version catalog in your Android projects or just some other projects, you need to update Gradle, and for the Android with the Gradle, you need to update Android Gradle plugin as well. So it's not very widely spread like until now, but it will be really popular in the next year, I promise. So version catalog. Okay, what we have first is type safety. I will show you examples, of course, but just to explain it beforehand, type safety, which is a great thing. I would sell all other advantages of this feature just for the type safety. Second is that it's official standard for managing the dependencies for libraries, plugins, and there are also some other cool features, but this is official standard by Gradle, which is like adopted already by Google and other companies. That means the tooling, the future tooling, plugin development, library, everything will be much more easy because there is standard. If you want to develop some GitHub Actions step or some bot like Dependa bot only for the Android, which integrates with the version catalog, it will be easy because there is one standard. You just parse one file and you know what to do and what kind of data semantically you need to parse. So that's cool. Also, it supports bundles, which we will explore a bit later, but in a short, its bundle is a bucket of the dependencies. Imagine you have a bundle of the compose, and you can put materials 3, compose tooling, and other compose related dependencies in the bundle. So you have now one bundle, you can write implementation, this bundle, and you have all the dependencies all together in the project. So it's super simple, super easy to understand, and also it's easier to review in the code review process because there's less lines to track and you know what's behind. No cache loss because we have these included builds, composite builds, auto dependency updates. It's not supported yet by Android Studio to update that, but it's already supported by some projects on the GitHub where you can integrate it in the CI pipeline to have some bot which updates your versions, and yeah, that's really good thing and really convenient. Best practices and easy to set up. It is easy, much more easier to set up than the BuildSrc. To maintain it, because we will go through a bit later about this, but it's just one file to actually maintain, and the best practices. Currently, there are not so many articles and GitHub projects in terms of the best practices, but this will change because, as I mentioned, the Gradle is really pushing this forward, and the best practices will be all around this one idea that there is a standard, and okay, let's do everything we can, like the best effort to make this standard popular for everything. Oh, it's raining. Nice. Yeah, and one more thing. You can publish your version catalogs like plugins. So if you have multiple Android projects in a company, imagine your software development company, you are creating three like new project for every new client in a every 4 months, like quarterly maybe, and most of the stuff is the same. Like you have internal libraries, you have internal like unified setup, you set up the CI/CD pipeline the same way, you set up flavors and everything in Gradle in the same way. So also the dependencies are the same most of the time. So you can publish this version catalog to the Gradle or to your like somewhere internally, and then you can reuse in a different project. It's so cool, actually. So just to imagine where we started from Stone Age, from just simple Groovy scripts to actually handle a catalog as a building block in every project. So that's very cool. I'm really excited about this. Not very nice thing is that Android Studio support. So new Android Studios, the currently stable Android Studio is a Dolphin. Finally, Dolphin supports code highlighting in the version catalog. Before that, it was just the plain text without any highlighting at all, just white on black. Now it's supported just to highlight the text, to support the syntax. Nothing else is supported. There's no navigation, like to control click, go to definition, none of them. And not even in Flamingo, which is Canary, Canary 3, it's Flamingo, yes, not supported. Also, what's not supported is some refactoring tools in there. So to actually handle as a version catalog and some kind of special unit, no, it's just text editor. And it shows just error that it's not supported. I'll show you a bit later. So let's go through what's this version catalog and how we can create this. We have only this file, which is libversions.toml. This toml is the extension, and this is supported in the newer Android Studio. So you get the code highlighting on this file extension. So libversions is the name that are suggested by Gradle. You can name whatever you want, but to keep it simple and to actually follow this standard and make it like unified and the same across all the projects on a GitHub, it's better to call it just simple libversions toml, and that's it. We have four major, four major, and that's all. There are no other blocks yet. I don't know what can be in the future, but four blocks like pillars, which is part of the every libversion toml. You can omit maybe bundles and plugins, but you definitely need to use versions and libraries. So versions are just to define the library versions. There's nothing fancy about this, and this can be referenced by the libraries and the plugins a bit later. You can use the dash symbol there, which will be handled by Gradle inside the catalog and also in the scripts. We will see a bit later. So those dashes convert to the dots. That's it. So libraries, so you define the libraries, whatever you want, and reference it with the version. bundles, which are just a set of dependencies for compose, maybe for you can create testing bundle, which will include Hamcrest, JUnit, maybe Mockito. That's a completely different debate, but I'm not a fan of the mocking. So lots of stuff, and make it as a single bundle and implement it everywhere. And plus you can define your own plugins, not your own only, but all the plugins. If you are using Hilt plugin, if you are using any other plugin, you can just list it in the version catalog, reference it with the version, and you are good to go. And let's go through the steps and see how we can create this version catalog and how can we use it in a project. So simple steps, there are just 4 steps, and okay, let's see. First is that we need to create this file, the lib versions toml, which goes most of the times, and as it's stated in documentation, goes to the root Gradle directory where you have the Gradle wrapper. You can drop it in other place, maybe in a dedicated folder, but it's easier to keep it there. And yeah, that's it. Yeah, this is on the right hand side. You see where it's located. On the left hand side, I tried to list many dependencies here just to show how it might look like. This is the live screen from the Android Studio's latest version, latest stable version. As you see, there is a code highlighting, but that's it. That's it. The whole support of the Android Studio. So don't build up any hopes for now. Okay. Maybe in the future, Android Studio can provide some migration tool to generate version catalogs from the existing dependencies, but currently this is very, very hard to achieve with the current situation with the Android Studio. Plus, it's still hard to develop as a bash script, as any kind of binary. So I saw only one project that offered this feature to convert existing libraries to the version catalog on the GitHub, and I will share the link at the end of the slides. I have referenced in the slides. But yeah, if you want to migrate at this point, you probably need to do some hard work and manually list those different dependencies. So just to quickly go through, it's not visible well enough, but yeah, okay. So we have versions, all the different versions. Then we have libraries, and the syntax is very easy. You just list the name, on the left-hand side, it's activity dash compose equals, and you just assign what the library name. So the module is AndroidX dot activity double colon and then activity compose. And then you assign the version. That's it. Now you have declared your dependency. Same goes to the plugins. You just define this in square brackets that the next lines will be plugins, and you list all your plugin dependencies there. So imagine now if you want to develop or if you want to reuse some binaries or scripts to parse this file from GitHub or something like this, it's really convenient because you know what to expect. So you will just search up with the regex where the libraries block, you parse all the libraries, then you know that, okay, next line is a bundles. So you can really extract what are the libraries, and then you have version.ref. So you know that there's a version reference and hook up with the versions. So that's why it's a standard, and you can really follow to that. The bundles, which I explained a bit earlier, it's quite easy to reuse. if you have defined all the libraries above, which are the Compose UI, UI tooling, everything, you can use it in bundles. Just keep in mind that the names, we had the dashes there, but when we list them in, like, when we make them as an items of this Compose bundle list, we need to reference them with the dot. So in the compilation time, those dashes will be converted to the dots, and yeah, that's it. So just use the dots instead of the dashes in the bundles, because those are strings, and those will be compiled then, fixed, replaced, and will be converted to the strings in the compilation phase. So that's why we need to prepare them as the dots. Yeah. Yeah, almost there. We are getting there. So let's. Next part is to create Gradle plugin. Here is the catch. So you have actually two different ways to proceed on this step. The first one is you can create your own dedicated Gradle plugin just to host this version catalog, or you can reuse existing settings Gradle script and declare your version catalogs there. Both of them are okay, but today's topic is the version catalogs plus conversion plugins. So let's create this plugin, and we can reuse it a bit later. So if we want to get this super nice features in the end. So okay, let's create just a simple Gradle plugin. It's just another module. We can just drop the build Gradle KTS and settings Gradle KTS. Okay. You need to use Kotlin script. You can't use the Groovy there. So yeah, we need Kotlin from now on. Yeah, okay. We create this plugin, and it's super simple. Most of the stuff is already generated by the ID. The only stuff you add is Kotlin DSL, the plugins block, and repositories is very trivial. And on the right-hand side, everything is done in the settings Gradle, in a root settings Gradle. And we just need to add the versions catalogs block. But if you want to create new plugin, you just need to copy this whole block, like dependency resolution management and so on. And here we referenced it in a Gradle's root project and lib versions toml. Here, as you may suggest, we can change the name, we can change the location, everything. And if you look carefully, it says that files and then list goes through the directory. Instead of files, we can put the string there, which will be referenced to the published version catalog. So you can actually fetch version catalog like the plugin and fetch it from the repository. So very convenient. Okay, and the last step is just to hook up with our root project. In root settings Gradle, we just add the one single line include build. It's a build logic folder, like build logic plugin. I named it like this because most of the project will use this naming build. And if you are familiar with the repository now in Android, it's a very nice application which showcases all the modern Android development techniques and architecture now in Android. So that project, it also uses the build logic names there. So that's it. Little catch. If you are using lower versions than 7.4, you need to enable that feature like this. Otherwise, it's enabled by default. That's it. Now, this is how we use it. To showcase, here's a plugins block. So you need to just use the alias keyword there and fetch it from the leaves, plugins, Android application, whatever you want. Android.application is the name. And initially we had like Android dash application, and it's converted. And the libs.plugins is that you have this lib versions terminal, libs.plugins block, Android application. Very easy. In the future, Android Studio should provide autocomplete, and this will be very trivial to set up, but now you have to type it manually. And with the dependencies, you have the same. You have libs, and then just the name of the dependency, libs core KTX, libs lifecycle runtime, and bundles. So you have libs bundles compose, and if you go back, a bit back. Oh, I hate these animations. In a compose bundle, we have compose UI, UI tooling, activity compose, materials tree. So instead of listing those dependencies separately, you have one-liner configuration, and that's it. Libs bundles compose. And I've seen lots of projects who extract those dependencies in a separate Gradle script. Like if you have 40 different feature modules and most of the feature modules use the same setup, why don't you just extract Gradle script like common feature dot Gradle, and you have all the setup, all the required setups there, and then include this Gradle script into your feature. And so yeah, it's very easy, and it was the not official, but the most popular way to extract some logic and the dependencies in a one single place from all those modules. And here is a catch. So, there are some drawbacks which are not very good at this point, but you cannot use this type safe way in the precompiled scripts. So if you had the Gradle script extracted somewhere as just a Groovy script, Groovy file, you cannot use the version catalog there. So if you want to migrate to version catalog, there are two options. You refactor your Gradle script, or there's type unsafe API, which is just the default way we've been doing the applications all the time. And here's the type unsafe API. Basically, like it's all the same that we had this for years. We just get the extensions get by type that we want versions catalog type. We search with the name, which is libs for us, and then okay, let's list the dependencies. We just open dependencies block as we used to, and then find the dependency, for example, Groovy JSON, and if present, implement it, or API it, or whatever you want, compile only, it's up to you. So basically this is type unsafe API, and either use this or refactor to the different Gradle script and make it dependent on the how it's called version catalog. Okay, this is the error what Android Studio shows you when you open the versions catalog. Some editor tools may not work as expected. I'll tell you, only highlighting works, nothing else. So yeah, bear with it. Okay, we still have some time, so let's go through the convention plugins. Convention plugins is a fancy word just to define the reusable Gradle plugin, which can help us to configure our project. But the main point is that it follows this rule that convention over configuration. So until now, you've been configuring your builds not in the smartest way. I mean, the scripts were, I bet it were good, but it were tedious process because you need to somehow extract feature related Gradle script JVM only libraries Gradle script, maybe libraries common scripts, and so on. Now we can do it in a plugins. Historically, Gradle plugins were very hard to write, then test it, publish it, but conventional plugins are not. And this is really good. That's why we can reuse it every time we want to scale our project in terms of the team size, or the feature modules are increasing, however you want. Okay, this is standard API from Gradle again, and because it already from the Gradle there are provided base classes and so on, you can assume that in the future there will be many interesting solutions from the community, and also lots of good answers on the Stack Overflow and good projects on the GitHub. But for now, you can follow Now in Android. Basically, Now in Android is a large project already, which includes multiple convention plugins, and you can go through the code, explore it. It's really cool. So this is just to share build logic, and it's composable, not the Jetpack composable, but it's like a building blocks, and we can really build from small bricks, gradually to the complex logic. This is what Square is using, and they had the blog from the last year, I believe. It was very popular, but the community was like, what's that? So that's a convention plugin. Okay, yeah, here's another catch. Type unsafe API is the only way to use in convention plugins. I don't understand why it's like this, but basically, if you want to declare dependency in the convention plugin, you cannot use version catalog. Okay. Yeah, okay, let's go through the steps we need to actually implement convention plugin and build our first convention plugin. First one is, we are not creating another plugin because we already have the plugin and we can reuse this, and just we need to add some lines to it. On the left-hand side, it's build Gradle, and we just add the Gradle plugin block where we define what's the name of it, what's the main implementation class it holds, and what ID we need to assign. This ID is a plugin ID, which can be reused later, like android.application or something like this. And on the right-hand side, we just need to include, like any other project, include convention, and that's it. Okay, show me the code. Let's start with, you write in Kotlin. That's it's automatically assumed, but yeah, again, good to highlight. So we have this the class name, which we referenced in a Gradle here, Android Application Convention plugin. It's a kind of hard name, but I'm very bad at naming, sorry. And we have one function which we need to override. It's just standard plugin function, it's apply, and we have target project. Then we have different options to do, but the purpose of this plugin is to configure app module. So app modules have the Android application. It's a single entry point. And why don't we apply those plugins in our conversion plugins so we can use our own plugin, and that's it. There's no other plugin needed. So for this, we just list the plugins we need to apply, Android application, JetBrains Kotlin, and then, okay, let's configure our app module, like what SDK we want to support, like minimum SDK, what should be the target SDK, and so on. So we set all these properties. Sometimes, most of the times, Android Studio gives you suggestions, code completions, but very rare occasions, like I had few times, autocomplete is broken, code highlighting is broken, and basically you clean cache, you invalidate Studio, sometimes uninstalls, like dark magic. But honestly, it happened to me, so I'm not lying. All the blame goes to the Studio. So. And then we can apply default config like the target SDK, min SDK, what could be the application ID. Of course, you can extract those in the extension functions, some fancy Kotlin looking functions, but just for the sake of complexity, simplicity, let's put it like this. And then our typical source compatibility block, which this is a config which is shared by many like many projects. Basically those are the same, the source compatibility, versions, everything. And you can extract some parts of it, and then you can publish your own plugin, and yeah, you can reuse it in every application you have. So imagine scale of this composability and modularity. So it's crazy, and it's really nice. And then this is how we use it. Instead of listing all those plugins and the configs there, we just call this one plugin, which is our own plugin. The name is from what we named in the build settings. Sorry, builds KTS, Gradle KTS, and that's it. That's really it. Let's see how it's handled in now in Android. So now in Android also has different plugins. The application compose, which set up the compose code, Choco, healed, but everything is coming from their own convention plugins. So if you go to now we don't have enough time, but if you go to the now in Android source code, there's tons of good code written about the convention plugins, but this is the main building block. This is the main building block, and from this you can build whatever you want, and you can apply it to the feature or any other library modules. And here is the example how it's like in a if you want to use version catalog in the convention plugin, this is a code snippet from the now in Android code base. So it's type unsafe API, basically extensions get libs. And then we need, most of the times we need desugaring libraries. So add just desugaring library with the proper library dependence. That's it. I will share the slides afterwards. It's already on a speaker deck, so I will share it in the event. So you can go through that links and find the good resources to get started. If you have any question, don't hesitate. You can ask right now or afterwards on Twitter, on LinkedIn, and I'll try to give help. So grazie, and if you have any questions, I'm here. Yes. Is this feature we okay. The question is that if we can use okay. I'm repeating for Zoom viewers. So to use in just simple Java Kotlin based project or only in Android. The answer is that you can use in both realms. So it's just a Gradle feature. So it can be used where the Gradle build system is. Just expect this almost same support from the IntelliJ, because Android Studio Flamingo is based on the previous IntelliJ, so there's not much difference. So support will be same. Okay, I guess there are no other questions. Thank you for having me again. And yeah, I'm available to chat after this session and yeah, on Twitter as well. Thanks.